The moment the sun stops burning. Imagine waking up one morning to find that the sunlight that warmed your skin, the golden rays that painted the sky, and the very energy that gave life to Earth was gone. The sun, the blazing heart of our solar system, has stopped burning. Of course, the sun doesn't really burn like fire on Earth. What we call burning is actually nuclear fusion, a process happening deep inside the sun's core, where hydrogen atoms fuse into helium, releasing an unimaginable amount of energy. Every second, our sun converts 4 million tons of its mass into pure energy, enough to power all of human civilization for millions of years. But what if that process suddenly stopped? The moment nuclear fusion halts, the sun's engine dies. Its inner pressure, which balances against gravity, collapses. In reality, the light we see from the sun is already 8 minutes and 20 seconds old, because that's how long it takes light to travel from the sun to Earth. So when the sun stops burning, we wouldn't know it right away. For 8 short minutes, everything would seem normal. Then, darkness. The sky would suddenly turn black. The moon, no longer illuminated, would vanish from sight. Stars would still glimmer faintly, but Earth's days would end in an eternal night. The first effect would be purely visual, but quickly, the deeper consequences would begin. Within a few days, the average temperature on Earth would drop by 15 degrees, 27 degrees. Within a week, it would be below freezing everywhere. And after a year, the global average would plunge to 73 degrees, 100 degrees, cold enough to freeze the oceans from the surface down. But the real problem isn't the temperature, it's energy. Nearly every ecosystem on Earth depends on sunlight. Plants perform photosynthesis, turning sunlight into chemical energy, the foundation of our food chain. Without sunlight, photosynthesis would stop almost instantly. In a matter of days, plants would begin to die. Within weeks, herbivores would starve. And then the predators. NASA's Goddard Institute for Space Studies once modeled a similar scenario. They found that even with all our technology, human life would struggle to survive more than a few decades without solar energy. But that's only the beginning. Without the sun's gravity, which keeps the planets in orbit, the solar system itself would begin to unravel. You see, the sun's gravity is what keeps Earth and all other planets circling it like a cosmic dance. If the sun were to vanish completely, the planets would no longer orbit. They'd fly off in straight lines into the frozen void of space. However, if the sun stopped burning but still remained massive, say it became a black dwarf, a theoretical cold remnant of a dead star, its gravity would continue to hold us. Earth would keep orbiting, but around a dark, lifeless sphere. It's fascinating and terrifying to realize that we rely on something 150 million kilometers away for every breath, every heartbeat, every sign of life. The sun is not just a star. It's our origin, our sustainer, and one day, our destroyer. So, what would humans do when faced with an eternal night? Would we find a way to survive? Or would Earth become just another frozen tomb floating in the dark? Before we answer that, if you're fascinated by this kind of science storytelling, the impossible truths about our universe, make sure you hit subscribe right now. Your support helps this channel uncover more mysteries of space and time. And trust me, what comes next will shock you even more. Let's continue. Humanity's struggle for survival. The first few hours after the sun goes dark would be filled with confusion. Electric grids would flicker, panic would spread. People would rush outside to see what had happened, only to find a sky completely black. Then, as the realization sets in, fear would give way to silence, no longer producing energy. But while the light has vanished, the sun's gravitational pull still exists. For now, Earth continues to orbit a dark, invisible core. Within the first week, photosynthesis would stop entirely. Forests would begin to fade, grasslands would turn gray, and the oxygen cycle would slow down. Animals dependent on plants would start dying off. The collapse of the food chain would begin. Governments would activate deep bunker systems, places once built for nuclear war. Power plants would switch to emergency energy sources, nuclear fission, geothermal heat, and stored solar reserves that might last only a few years. NASA scientists have long studied the geothermal potential of Earth. Even if the surface froze, the planet's core, still thousands of degrees hot, would remain a source of heat for millions of years. That means deep beneath the surface, in geothermal tunnels or near volcanic zones, life could continue for a while. But survival would not be easy. Temperatures would continue to plummet. By the end of the first month, the atmosphere would begin to condense. Rain, snow, and sleet would freeze into thick layers of ice. Eventually, the oceans would freeze solid, except for pockets of liquid water trapped beneath the frozen crust, similar to Europa, one of Jupiter's icy moons. That's right. Our planet would begin to resemble a distant moon of Jupiter. Dark, icy, but still warm deep below the surface. And where there's heat, there's still life. Deep-sea vents, powered by geothermal energy, could continue to support microscopic organisms, just like those discovered in Earth's deep oceans today. These life forms don't need sunlight. They feed on chemosynthesis, drawing energy from the minerals spewing out of volcanic vents. It's proof that even in total darkness, life can persist, something NASA scientists believe could also exist on Europa or Enceladus. But what about humans? Scientists have theorized that underground habitats could be powered by nuclear reactors and geothermal heat exchangers. Massive enclosed biospheres, artificial habitats like those once tested in Biosphere 2 in Arizona, could recreate mini ecosystems. Inside, LED lights powered by nuclear batteries could simulate sunlight for growing food. And if humanity cooperates globally, there's a small chance civilization could continue, but only for a few thousand years. Without sunlight, photosynthesis would remain impossible, and food supplies would become limited to fungi, algae, and artificial production methods. Earth's surface would become uninhabitable, a silent wasteland covered in ice thicker than the height of Mount Everest. The last remaining astronauts on the International Space Station would look down at a frozen planet and realize they were witnessing the death of their home. And yet through the despair, humanity would not give up. Using geothermal and nuclear fusion research, scientists would begin searching for a way to reignite the sun, or at least migrate to another system. Projects like the Breakthrough Starshot Initiative, which aims to send probes to nearby stars like Proxima Centauri, could suddenly become humanity's only hope. If we could build ships capable of traveling between stars, we might one day find another sun, another home. But that's easier said than done. The nearest star system is over 4.24 light-years away, meaning even our fastest spacecraft would take tens of thousands of years to reach it. The truth is sobering. Once the sun stops burning, Earth's time is limited. Still, deep beneath the frozen surface, remnants of humanity might endure, a testament to resilience. They would live in artificial caverns powered by geothermal energy, teaching future generations about the bright days that once filled the sky. Maybe they would look up at ancient records and wonder what sunlight looked like, or how it felt to feel warmth on their faces. It's a haunting vision of what our planet could become, but it's also a reminder of our strength as a species. Second right now. Hit that like button and subscribe to Impossible Truth. The next part of this story will reveal something shocking. What if the sun's death triggers a chain reaction, one that could reshape the entire solar system? The collapse of the solar system, the sun has stopped burning. Earth is now a frozen world, clinging to the last warmth of its ancient core. But as our planet slips deeper into eternal night, something even more terrifying begins to unfold. The solar system, once a harmonious cosmic dance, starts to break apart. The sun's energy didn't just give light and heat, it created stability. The fusion reactions at its core provided an outward pressure that perfectly balanced the inward pull of gravity. Now that fusion has stopped, that balance is gone. At first, gravity takes control. The sun begins to shrink, slowly collapsing under its own weight. Over weeks, it compresses into a smaller, denser object, a white dwarf, a corpse of a once living star. Its surface cools, fading to black over billions of years, until only a black dwarf remains, an invisible remnant, cold and lifeless. But before that final transformation, there will be chaos. As the sun collapses, it releases bursts of radiation and magnetic shock waves that ripple through space. Planets like Mercury and Venus, the closest to the dying sun, are the first to be torn apart. Their orbits decay, their crusts crack, and gravity slowly pulls them inward, feeding the sun's collapse. Earth remains in orbit for a time, still tethered by gravity, but every day brings instability. The gravitational balance that once kept planets in their perfect paths begins to wobble. Small deviations in orbit start to grow. Asteroids and comets, once held steady in the Kuiper Belt, are thrown out of alignment. Collision sends massive shock waves across the solar system, reshaping it into chaos. NASA scientists studying stellar evolution believe this collapse is inevitable for all stars. Every star in the universe, even ours, will one day exhaust its fuel and die. It's not a question of if, but when. According to astrophysicists, the Sun is already 4.6 billion years old and about halfway through its life. In another 5 billion years, it will indeed begin to die, expanding into a red giant, swallowing Mercury, Venus, and perhaps even Earth. But in our imagined scenario, that process happens instantly, and the solar system must face what would normally take billions of years, compressed into days. Astronomers have observed similar things in distant galaxies. Rogue planets wandering through interstellar space, alone and frozen. If the Sun's death were sudden, Earth could become one of them. A rogue planet, drifting endlessly through darkness, forever separated from its home star. But here's where the science gets truly fascinating and frightening. If the Sun's gravity were to weaken during its collapse, it could create what astrophysicists call a gravitational slingshot. That means planets could be hurled into space at incredible speeds, thousands of kilometers per second, ejected from the solar system entirely. In fact, astronomers have already found these rogue planets wandering the Milky Way. NASA's Nancy Grace Roman Space Telescope, set to launch in this decade, will study these dark worlds, planets floating freely without a star. Some scientists believe there could be billions of them in our galaxy alone. This isn't just science fiction, it's based on real planetary studies. Astrobiologists have found that tidal heating, radioactive decay, and geothermal activity can keep subsurface oceans warm even without sunlight. That means life, at least microbial life, could survive on a frozen Earth for far longer than we imagine. Mars, no longer warmed by sunlight, would turn into a deep freeze desert. Jupiter's atmosphere would collapse and Saturn's rings, made of ice and dust, would disintegrate into space. Even Pluto, on the edge of the system, would vanish into the void, its icy heart untouched by light forever. And yet, even in this cosmic catastrophe, the laws of physics continue. Gravity still pulls, time still flows, and the remnants of our sun, though dark, would continue to influence the space around it for billions of years. The universe doesn't end with destruction, it evolves. Stars die, but their elements, hydrogen, helium, carbon, iron, are recycled into new stars and planets. In fact, the very atoms in your body were born from stars that exploded long before our sun existed. So perhaps even if our sun dies, its matter could someday form another system, maybe even another world like ours. If that idea fascinates you, if you want to explore how death in the cosmos leads to new beginnings, make sure to hit that subscribe button right now, because in the final part of this video, we'll explore what happens after the sun's death, how the universe reclaims its energy, and what that means for the future of life. The universe after the sun. The sun has gone dark. The solar system lies in ruin. Frozen planets drifting like ghosts through an endless void. But even in the face of this cosmic death, the universe continues. Because in space, nothing truly ends, it only transforms. When a star dies, it leaves behind a legacy written in atoms. We are made of star stuff. And now, as our own star fades, that cosmic cycle begins again. Over time, the remains of the sun, a white dwarf slowly cooling into a black dwarf, will drift through the galaxy. It won't shine, but its gravity will still whisper through the darkness, influencing other stars as it moves through the Milky Way. Nearby, other stars will continue their lives, some growing, some collapsing, and their deaths will scatter new elements across the interstellar medium. That gas and dust will someday collapse again to form new stars, and perhaps new planets. NASA's Chandra X-ray Observatory and the James Webb Space Telescope have already witnessed the aftermath of dying stars. Glowing nebulae, clouds of gas that form stunning cosmic structures like the Crab Nebula or the Helix Nebula, sometimes called the Eye of God. These are the graves of old stars and the wombs of new ones. In one of those future nebulae, a new sun could ignite. Its planets might one day orbit in perfect harmony, warmed by its light, and on one of them, life could arise again. Maybe intelligent beings, thousands or millions of years from now, will gaze up at their star and wonder, how did this all begin? And the atoms that once formed our sun might be part of that very question. That's how the universe heals itself. Destruction gives birth to creation. Darkness is never permanent. It's just the space between one spark and the next. But what about us? If humanity somehow survives the death of the sun, perhaps by harnessing nuclear fusion or migrating to another system, we would become a multi-stellar species. We might build generation ships, massive vessels designed to travel for centuries, carrying the last fragments of human civilization. Already, real scientists are exploring this possibility. Projects like Breakthrough Starshot aim to send microscopic spacecraft to Alpha Centauri, our nearest star, using laser propulsion. And futurists like Dr. Michio Kaku and Elon Musk believe that, in time, humanity must become a Type 2 civilization on the Kardashev scale, one capable of harnessing the full energy of a star. That means not just surviving the sun's death, but mastering stellar power itself. Imagine surrounding a new star with a Dyson sphere, an enormous energy-harvesting structure capable of capturing all its radiation. It's a concept first proposed by physicist Freeman Dyson, and while it sounds like science fiction, NASA and multiple engineering think tanks have published real feasibility studies on how such megastructures might work. But if we fail, the Earth will remain silent, frozen beneath layers of ice, a relic of what once was. Maybe someday, a passing civilization, alien or human, will find our world drifting through the void. They might dig through the ice, uncovering traces of our cities, our art, our words, and wonder who we were. And perhaps in some poetic way they'll know, we were the children of a dying star. We lived because our sun burned bright. And when it stopped burning, we remembered, even the brightest lights must fade so others can shine. Across the galaxy, billions of suns still burn, some younger than ours, some older. And somewhere deep in that cosmic sea lies the next world waiting to give rise to life. A second Earth, a new beginning. That is the beauty of the universe. It never gives up on creation. So, as you finish this journey through time, space, and imagination, remember this. Every sunrise you've ever seen is a gift of fusion, a reminder of how fragile and miraculous life truly is. Story moved you. If it made you look at the sky differently, please like this video and subscribe to Impossible Truth. We bring you the wonders and mysteries of the cosmos, one impossible question at a time. And don't forget to check out our other full videos, like What If the Sun Disappeared? And The Strongest Magnetic Fields in the Universe. Because the deeper we look into the universe, the more we discover about ourselves. Until next time, keep wondering, keep learning, and keep your eyes on the stars. Because even in darkness, there's always light.